For decades, we've gazed into the cosmos, hunting for signs of worlds beyond our own. Not just distant planets or faint signals, but those fleeting visitors that wander in from the stars. And now, in the summer of 2025, the James Webb Space Telescope has turned its unblinking eye on the third such interloper ever recorded in our solar system, the interstellar Comet 3I/ATLAS. What started as a routine sweep by ground-based telescopes has unveiled a cosmic traveler that's both familiar and strangely defiant of expectations. A comet hurtling at over 130,000 miles per hour, glowing with an unexpected emerald hue, shedding dust in ways that puzzle astronomers. Is this just another icy relic from a forgotten star system? Or does it whisper secrets about the universe's wild early days? Why does it matter? Because 3I/ATLAS isn't just passing through. It's a time capsule hurtling toward our sun, offering clues to how solar systems form, what lurks in the galaxy's fringes, and perhaps even the odds of life elsewhere. Join me as we unpack the data, chase the anomalies, and explore what this interstellar comet tells us about space exploration's next frontier. Buckle up. The stars are closer than you think. Let's rewind to that fateful moment in early July 2025. Picture a quiet observatory in the Chilean Andes, where the ATLAS survey, NASA's Asteroid Terrestrial Impact Last Alert System, scans the night sky for potential threats from space. On July 1st, they spot a faint streak, a fuzzy dot moving against the backdrop of stars, too fast and on too odd a path to belong here. Pre-discovery images trace it back to June 14th, captured by other ATLAS scopes and Caltech's Zwicky Transient Facility. This isn't some backyard asteroid. Its hyperbolic trajectory screams interstellar origin, eccentricity clocking in at a whopping 6.14, meaning it's unbound by our sun's gravity and won't stick around. It's the third confirmed visitor from beyond, after the enigmatic cigar-shaped Oumuamua in 2017 and the more comet-like Borisov in 2019. But 3I/ATLAS, it's bigger, brighter, and already stirring debate. Estimated nucleus size, somewhere between 1,444 feet across, at least Manhattan-sized, and up to 3.5 miles wide, based on Hubble's sharp gaze from August 20th. That's a beast, thousands to millions of times more massive than its predecessors. Why the hype? Interstellar objects like this are rare cosmic billboards, advertising the chemistry and dynamics of alien star systems. As it barrels in from the direction of Sagittarius, approaching from Jupiter's orbit about 410 million miles out, scientists knew they had a narrow window to study it before it slingshots out forever. Fast forward to August 6, 2025, and enter the star of the show, NASA's James Webb Space Telescope, orbiting 1 million miles from Earth at the L2 Lagrange point. JWST wasn't built just to snap pretty pictures of galaxies. Its near-infrared spectrograph, NIRS-PEC, slices through cosmic dust to reveal hidden compositions, temperatures, and motions. When it locked onto 3I/ATLAS, the data poured in like a digital avalanche. A preprint hit ARXIV soon after, detailing an active comet with a bright coma of gas and dust enveloping its icy core. Unlike Oumuamua, which tumbled silently without a tail, 3I/ATLAS is alive with activity, outgassing up to 120 kilograms of dust per second even beyond Jupiter's orbit. Hubble complemented this with a stunning July 21st image, a teardrop-shaped cocoon of dust streaming from the nucleus, elongated and asymmetric, hinting at uneven heating or spin. Think of it like a cosmic ice cream cone melting in the sun's warmth. The dust isn't just trailing behind, it's sculpting a shape that defies simple models. JWST's infrared eyes caught the heat signatures too, mapping temperatures that suggest a layered interior, perhaps primordial ices preserved for eons. This isn't speculation, it's raw data from instruments honed over years of calibration, reminding us how space exploration tools like JWST turn what if into here's how. But here's where things get intriguing. 3I/ATLAS isn't playing by the usual rules. Take its glow, initially reddish, like most distant comets dusted with solar system organics. It shifted to a vivid emerald green by mid-September 2025 as it neared the sun. Astronomers watching from Hawaii's telescopes scratched their heads. What flipped the switch? Outgassing of cyanide and nickel, that's what. Gushing in a superlinear burst, not tied to simple photon flux or steady warming, but kicking in like a threshold crossed, producing tiny icy grains that scatter light differently. It's as if the comet hit a temperature sweet spot, unleashing a plume opaque enough to tint the whole show green. And that jet? Hubble spotted one pointing forward, toward the sun, 10 times longer than wide, a rarity that scatters sunlight ahead instead of dragging a tail behind. No cometary tail at first, despite the activity label, and an extension of light oddly sunward. Natural? Absolutely, say most experts. Just quirky sublimation from an uneven surface. But it echoes Oumuamua's non-gravitational acceleration, fueling, huh? Moments in the control rooms. Fun fact, at peak it'll hit 12th magnitude, visible with an 8-inch scope if you're in the southern hemisphere. Grab your binoculars, history's unfolding. Diving deeper into its makeup, JWST and NASA's SphereX mission, launched in 2025 to map the sky's infrared glow, painted a portrait of ancient origins. Carbon-rich to the core, with abundant carbon dioxide and water ice, but scant carbon monoxide, unlike the water-dominated comets in our backyard. That's a red flag for formation. It likely brewed in a protoplanetary disk over 7 billion years ago, twice the sun's age, in a metal-poor environment where CO freezes out early. Models tracing its 4.27 million-year backtrack using Gaia's star maps point to the Milky Way's thin, thick disk border, a chaotic frontier of old sparse stars from the galaxy's youth. Imagine this icy wanderer, ejected by gravitational mayhem from some long-dead system, has roamed for billions of years, collecting scars from passing stars. One minor tug from a sun-like neighbor barely nudged it. But overall, it's a survivor. And the chemistry? Traces of nickel outpacing iron, mirroring industrial alloys more than natural ices, plus extreme negative polarization in its light, scattering that screams complex particles. Coincidence? Or a hint of exotic processes? Scientists lean natural, perhaps vaporized metals from a crust baked by distant radiation. Yet it challenges us to rethink comet diversity. Our solar system's icy refugees might be the oddballs, not the norm. Now let's plot its wild ride. Clocking 210,000 kilometers per hour, 3I/ATLAS is the speediest interstellar guess yet, slicing through space on a path that's eerily tidy. Aligned within 5 degrees of the ecliptic, the plane where Earth and planets dance, with odds of just 0.2% for random chance. And get this, its timing lines up to buzz near Mars, Venus, and Jupiter, a 0.005% fluke. ESA's Mars Express and NASA's Perseverance rover got a front-row seat as it passed within sniffing distance of the red planet around early October 2025. Their instruments hunting for any influence on Mars' thin air. Perihelion hits October 30th at 1.4 astronomical units, just inside Mars' orbit, 130 million miles from the Sun, where solar heat will crank the outgassing to max. Closest to Earth, a safe 1.8 astronomical units, 170 million miles. No doomsday vibes here, despite the tabloid chatter. After that, it fades behind the sun till December, then vanishes into the void. Compare it to Borisov. That one had a classic tail and water jets, 3I/ATLAS. More restrained, like a reluctant tourist eyeing our neighborhood before bolting. Rhetorical question. If trajectories like this are common, why so few visitors? Maybe the galaxy's highways are lonelier than we thought. Of course, no interstellar story skips the anomalies, and 3I/ATLAS has a laundry list, courtesy of Harvard's Avi Loeb and teams worldwide. 7 standouts, that massive size and mass, the sun-pointing jet, nickel-heavy plumes over iron, wild polarization, ecliptic alignment, planetary flyby timing, Even a directional nod toward the 1977 WOW signal spot, odds 0.6%. Loeb, ever the provocateur behind Oumuamua's light sail theory, rates this a solid 2 on his Loeb scale for tech odds. Not screaming artificial, but not 0 either. He argues dogmatists must explain every quirk as natural, from threshold outgassing to trajectory tweaks. Mainstream view. It's all kosher comet chaos. Dust dynamics for the jet, primordial scarcity for the chemistry, gravitational echoes for the path. No signals, no course changes, just physics doing its thing. Theoretical aside, if engineered, imagine a dormant probe reactivating near stars. Fermi's paradox in ice form. But evidence points natural. A relic testing our models. Engaging, right? It pushes space exploration to probe deeper, blending skepticism with wonder. As 3I/ATLAS hurtles toward its solar close-up, the Global Observatory Network hums. Ground scopes in Chile and Hawaii, space assets like Hubble, and soon reoriented probes. Post-perihelion, it'll reemerge in December for a farewell tour, data flowing to Air Archive and journals like Nature. Implications? Huge for exoplanet science. Its CO2-rich ices mirror distant worlds spied by JWST, hinting at carbon-heavy atmospheres where life might brew differently. For interstellar travel dreams, it spotlights ejection mechanics. Rogue planets or stellar close calls could fling trillions more our way. And SETI, no pings yet, but alignments like the WOW. One invite radio sweeps. Who knows what echoes linger? This comet bridges eras, from the Milky Way's toddler tantrums to our quest for neighbors. It's a reminder. Space isn't empty. It's a gallery of stories, each visitor etching one more line. So what have we learned from this emerald streak across our sky? 3I/ATLAS is no mothership, just a rugged comet born in the galaxy's dawn, whispering of lost worlds through its glow and grains. Key takeaways. Interstellar objects are windows to alien chemistry, with JWST unlocking their secrets. Anomalies like color shifts in jets are natural quirks, not sci-fi plots. And its path underscores the universe's vast, untamed highways. But lingering questions fire the imagination. How many more like it roam undetected? Could its ancient ices hold organic hints of extraterrestrial life? What if the next visitor isn't so shy? Space exploration thrives on these riddles. They pull us outward toward missions like Europa Clipper or Dragonfly to Titan, chasing water and wonder. If this sparked your cosmic curiosity, hit like if you're Team Comet, comment your wildest theory below, natural or nah, and subscribe for more dives into JWST marvels, Mars updates, and black hole breakdowns. Check my playlist on interstellar mysteries for Oumuamua deep dives. Thanks for joining the Star Hunt. Until next time, keep looking up. The universe is watching back.